So this lesson is about functions, specifically operations with functions. So we're going to add, subtract, and multiply them, and it'll be very similar to the operations with polynomial stuff that you guys have previously done. So as a quick refresher, functions are just anything that takes an input and then based on some rule it's going to spit out an output. We typically talk about them with numbers or variables, but it could be anything. Like for example, a function could take in a fruit as its input. Like our function could take in a fruit, and then the output could be like, I don't know, you take the fruit and add like water and add sugar, that's the rule, and then it gives you some sort of juice. So like this is an input, that's the rule, and whatever you get would be the output. That's a function. Or for example, if I have the function f of x equals x plus 1, that says you have a function named f, the input is x, and then you're going to take the input and add 1. So if I were to put 5, I would get 5 plus 1, which is 6. Or Instagram actually uses this basic stuff for its filters, for some of its filters. For example, every pixel on an image is represented by red, green, and blue values, and each of those is a number. And so what they do is, like if you wanted to slide the little thing that makes it lighter or darker, what they're doing is they're literally just adding numbers to that pixel number, or they're taking it away in order to make it have more light or less light, and that makes it lighter or darker. So it's literally just a function. Here's another example, like if your input was 4, you put it into this function, you do 2 times 4 plus 3, and you'd get out 11. Okay, so now let's do just a little bit more review. Let's say we have the function f, its rule is you do 2 times the input, and g, its rule is 4 times the input minus 1. Let's do a few just quick problems here. First, let's do f of 3. Again, remember that means you're going to put 3 in for the input. X is just a placeholder for whatever your input is. So I'm going to do 2 times the input. In this case, the input is 3, which is 6. Hooray. If I wanted to do g of 1/4, that means put in 1/4 to the g function for its input. 4 times 1/4 is 1. 1 minus 1 is 0. So that's my output for this one. What if I wanted to do f of 6x? So this is a little different. This is saying take the function f and put in 6x for your input. So instead of an x, I'm going to put 6x. That's literally all you're doing. This x is just a placeholder, and I know it's confusing because there's like x here. I know that's confusing, but this is just a placeholder for whatever your input is. So put in 6x instead. So I'm going to do 2 times 6x, which is 12x. That one's a little different because our output actually had an x in it, and that's okay. It doesn't have to be a number. If you put numbers in, you usually get numbers out, and if you put variables in, you often get variables out. Let's do g of m. This means take your function g, the input should be m. Basically, I'm just replacing these x's with an m. So instead of x, I'm putting m. That's it. That's my output, because I can't simplify that at all. All right, what about g of 5a squared? So again, I'm just going to take out the current input and put in 5a squared. So g is 4 times the input minus 1 I'm going to take out the x and put in this, 5a squared. And that's it. I just need to simplify a bit. 4 times 5 is 20. That's my final output on this one, now that it's simplified. Okay, let's do just a couple more. I want to do g of x plus 2. Again, just take out the current input and put in x plus 2 in its place. So instead of g of x, I'm doing g of x plus 2. So I'll do 4 times the new input, x plus 2, minus 1. And that's it. I just need to simplify. In this case, I'll have to distribute the 4 because there were 2 terms in that parentheses. Here it was just 1 term, so we can multiply it all together. But here there's 2 terms, so I need to distribute. 4 times x is 4x. 4 times 2 is 8. Don't forget the minus 1. 8 minus 1 is 7. That's my final output on that one. Again, notice like if I put a stuff in, I usually get a's out. If I put x stuff in, I usually get x's out. Last one, let's do sometimes you'll see a number written right in front of a function, or maybe even with like a dot there. You guys know anytime things are written right next to each other or written with a dot, it means to multiply. This means I'm going to take the entire function, g of x, and multiply it by 3. Basically, I'm going to take this entire thing and put a 3 in front, and you'll need parentheses to keep this all together. So basically, it's 3 times g of x, and there's g of x. Again, need to simplify, so distribute that 3 and we're done. 12x minus 3. Okay. So now, let me erase these. Same functions, but now we're going to combine them a little bit. So, for example, let's do f plus g of x. F plus g of x literally just means I'm going to do function f, I'm going to add it to function g, and my input is still an x. It means the same thing as take f of x and add it to g of x. So all I need to do is combine f of x plus g of x. F of x was 2x, g of x was this, and I need to add them. So just combine like terms. 2 plus 4 is 6. Next up, I'm going to try f minus g of x. Same thing here. This just means take function f and subtract function g. It's the same thing as f of x minus g of x. These are just 2 different ways you might write this. So same thing that we just did, except subtract. Here's f of x, here's g of x. I'm going to subtract them. Be careful, if you're going to subtract g of x, you need to subtract the entire function, meaning you need to distribute that negative to both of those terms, anything that's in g of x. So that becomes negative 4x, negative negative is a positive 1, and then 2 minus 4 is negative 2x. That's my final answer. Okay. Let's try f times g of x. A dot, a closed dot means multiply. This is the same thing as take f of x times g of x. So I'm going to multiply the two together. F of x is 2x, g of x is this, and I'm multiplying them. So since there's two terms in here, I'll need to distribute the 2x to both of those terms. 2x times 4x is 8x squared. 2x times -1 is -2x. And last, we're going to divide. So let's say we did f divided by g of x. That's the same thing as f of x divided by g of x. So f of x was 2x. G of x is this. That's pretty much as simplified as that gets. I mean, there are ways you could do stuff with that, but there's nothing really to divide. Since there's two terms down here, I'm just going to leave it as it is. That one's done. Okay. So now what happens if we try to combine these and also put a number in? So for example, what if I wanted to do f plus g of 3? There are two ways you can do this, and either of them will work. What you can do is combine f plus g first, then put in the 3 as an input, or you can separate it. You could do f of 3, see what you get out, and add it to g of 3. Like, do these individually and add them together at the end. Let's actually try both and see if we really do get the same thing. If I want to try it this way, by combining the functions first, I actually already did that. So let's come back up here where we did f plus g, and we got this. So if instead of f plus g of x, I want to do f plus g of 3, then I'll put a 3 in for x. Basically, just put a 3 right here. Sorry if you can't see that. So 6 times 3 is 18, minus 1 is 17. So let's see if we do it separately, if we get the same thing. So let's do f of 3. F of 3 is 2 times 3, which is 6. G of 3 is 4 times 3 minus 1, just putting in a 3 for x. So that's 12 minus 1, 11. So f of 3 was 6, g of 3 was 11, and when I add them up, I get 17. The same thing I got the first time. So I don't care which method you use, either of them will work, but do whatever works for you. Let's try a few more slightly complicated examples here. Okay, what if we did f minus g of 3? Again, you can do it either way. You could do f minus g, like I could do this minus this, then put in the 3, or I could do them separately. F of 3 minus g of 3. I'm going to do it this way just for this problem. So f of 3 would be 2 times 3, which is 6. And g of 3, we did that already. What was it, 11? So this time I have 6 minus 11 rather than 6 plus 11. So negative 5. Let's try f times g of 3. Again, if you want to multiply the functions first and then put in the 3, that works. Or you could do f of 3 times g of 3. So 6 times 11, which is 66. All right, let's try just a couple more. Okay, so what if I had f plus g of x minus 2? Again, you can do this either way, but basically what it means is I'm going to take the f function with an input of x minus 2 and add it to the g function with an input of x minus 2. So if I were to take out this x and put in this input instead, I would get 2 times x minus 2. That's for f. For g, if I were to take out the x and put in this, I would get 4 times the new input minus 1. And then, since I'm adding, we'll add them. Quite a bit of simplification that we need to do here. I'll distribute the 2, so 2x minus 4, and I'll distribute this 4. The 4 doesn't go here, it only goes to what's in parentheses. So 4x minus 8, and then minus 1. Now combine any like terms. 2 plus 4 is 6x. That's negative 12, negative 13. That's going to be my final answer on that one. All right, just 2 more. What if I had this? F plus f of 3. We can do that. This says take function f and add it to another function f, and the input should be 3. So you could add them together first, like I could do 2x plus 2x, which is 4x, and then I could put in the 3. So 4 times 3 is 12. Or I could separate it and do f of 3 plus another f of 3. If I put in 3, I get 2 times 3, which is 6, plus another 2 times 3, which is 6. And if I add them, I also get 12. So again, you can do it either way. Last one, let's make this about as complicated as it gets here. Let's do 3f plus 2g of x. This says my input is x, so I'm not going to have to change the inputs at all. But I'm going to do 3 times the function f and add it to 2 times the function g. So I need 3 times this plus 2 times g. So that was 4x minus 1. All right, that's it. And then we'll simplify. 3 times 2 is 6x. 2 times 4x is 8x. 2 times negative 1 is negative 2. 6 plus 8 is 14x minus 2. All right, we're going to do one more example.